Alright, so two popular forms. So when you want to find v in terms of x, usually we'll be using this form for the acceleration. And usually when you want to find something related to time, you'll be using this form over here. Yeah.
You know that, look, if they're equal, right?
Yeah.
If they're equal, then that means, right, that dt on dx times v equals to 1.
dt on dx is equal to 1.
So times v equals to 1.
dt times what?
dx.
Yeah.
No, wait. dt on dx times v equals to 1.
You're just rearranging? Yeah. Cool. That's interesting, isn't it? I wonder if that's always true.
I wonder if that's...
The problem is that these don't actually have assigned, these aren't like variables, right? We're cheating when we treat them like fractions, kind of.
Doesn't v equal to dx dt? So it's just like that.
Yeah, I get what you're saying, but yeah.
1 equals 1.
Anyway, don't overthink the
Don't
overthink the chain rule thing, because we're kind of cheating when we do this anyway. So
we're kind of cheating, but it's part of the course.
it is, yeah. Okay, cool. So now sometimes they might give you the resultant force here, right? So for the resultant force, let's look at part A, right? We know that the resultant force is going to be F, so that's our F value here. All we need to do is replace our mass, which we get, mass is 2. And acceleration, this is where you need to choose your form, right? So if you want v in terms of x, typically you'll be using this one. That's the idea behind it. And we want to find v in terms of x, same kind of idea. You've got these kind of v's and dx's hovering around, and you notice that it's a separable form, right? So maybe you want to halve, do your algebraic rearrangement. Maybe we'll halve these guys first. So 3 minus 2x is equal to v dv dx. And you can bring your dx's over. And then take the integral, right? So what's that going to give us? It's going to give us 3x minus x squared is equal to half v squared plus our constant. And so they have to give you some initial values here. So when v is equal to 2, x is equal to 1. Actually, when you do this...
Why are they equal to 2v?
Where am I looking?
Why are they equal to 2 of it?
Because that's the mass, m. Yeah, so mass is 2, yeah. And then here, if you substitute in v is equal to 2 when x is equal to 1, I think you're going to get c is equal to 0, actually. So c is equal to 0, which is quite nice. Not too bad. Is that right?
What's 3 minus 1?
2.
Yeah, that's right.
Is that right? No?
Oh, whoops, I substituted v as 0.
So we can get an expression now. So we're going to get, since c is equal to 0, then we have, here's that expression over here. 3x minus x squared is equal to half v squared. V squared is going to be equal to 6x minus 2x squared. Now v, if I take the square root and I have two cases, what do I really need to do here? Oh, velocity is speed with direction, right? But then also we have some conditions here. When x is equal to 1, v is meant to equal to 2. So this is what we should be using here, right, to check, right? So v, so since v is equal to 2 when x equals to 1, you can just check the conditions. And when x equals to 1 here, you're just going to 6 minus 2, which is 4. So you want the positive case, exactly. So v is equal to just the positive square root of 6x minus 2x squared, okay? What about the next one? You want to try part B? Do you want to try part B for me? Just as a clue, right? You already know that you want something in relation to time. So you're going to have to use the other form here for this one in terms of that. They won't always be as explicit potentially. Maybe it's a bit more hidden in terms of what they want you to do. Maybe they'll ask you show some expression there and it's got t's and v's in it and you just have to kind of infer it that way. But that's the nature of the questions that we have here. Let's start this off. So F equals to MA. So resultant force is 8 minus 2v squared with our mass of 2. And acceleration, we want to use our other form now because we need to relate time together. So v dv dt. Yeah, pretty sure that's on your formula sheet. And then here we have to be a little bit creative because we can divide both sides by 2, right?
We're gonna have to like flip it, or what do we do with v?
I think it's not
Hang on. Did I do something wrong here? Oh, it's not dv dt. Sorry, let's go back. So this is why I get my things confused. Sorry, let's go back a step. Acceleration, how do we write that in terms of time? Like how do you, when we had our results that we could find,
Like in terms of what?
that what relates the
dv over dt.
dv over dt, so that's what it's meant to be.
But there's no B.
There's no v, sorry, that's the v dv dx. This is why I get myself confused, so it's like, yeah.
Oh, if we flip. Oh, I see what you did there.
Yeah, I made a mistake, yeah.
No, I see what's coming.
Oh, what's coming? So let's halve both sides.
Partial fractions,
That's exactly it. So dv dt.
actually.
So then what we need to do is we need to put the v's and the dv's together. The t's, well there's no t, so it's just like going to be a constant, right? But what ends up happening is you get, like 1 dt is equal to dv on 4 minus v squared. And if you're thinking, what kind of form is this? Well, Matt's already given us an idea. Like this is not your inverse trig, it's not a log because you don't have the derivative of the denominator and the numerator. Know all your options here, right? This is actually difference of 2 squares, which you can write as, you don't have to say it like that, 2 plus v, 2 minus v. And then let's just do a little bit on the side here. So as our partial fractions, we know how to integrate now.
No, go.
It's been a while. A, B, C, the usual.
Yeah. We want this equal to,
1, 2 plus V.
yeah.
Plus V, V, so I got 2 minus V.
Mhm.
And then A equals 2.
So so you multiply both sides by this guy here on the left. So we got 2 minus v
A
plus b outside of 2 plus v. So can you do it in their head?
Is it actually not going to be like a quarter?
Yeah, so I use the way where you substitute, v is equal to 2 or whatever to eliminate them. If you substitute v into 2, that goes away. And so you've got 4b, so b is equal to 1 and 4.
I think they're both 1 and 4.
Yep, and if you do the same for a, you substitute v is equal to negative 2 to remove that. Then you get 4a here, so a is equal to 1 and 4 again. Right? And so now we have our a and b values. So dt, let's take the integral both sides now at this point, is going to be equal to the integral of, so our partial fraction was a quarter on this and a quarter on this, but I'm going to write it as, I'm actually going to just factorize it out, actually, it's probably better. 1 out of 4 on 1 on 2 plus v, plus 1 over 4 on 1 minus 2 minus v. Okay. So a bit involved there, but we got there. So the integral of this whole thing. Oh, and I'm factorizing this out, aren't I? So we'll just leave it like that. So far, so good?
Yeah, 40.
Now at this point, just be careful when you're integrating with your logs here that, you keep in mind the negative here. So that should be like, if you want the derivative on the numerator, it needs to be -1, but then we need to change that to a minus as well. Yep. So then, what I'm going to end up with is on this left-hand side, it's quite nice, it's just going to be t is equal to 1 over 4 ln of, and this is where Cambridge would probably just remove the absolute values. Take away ln of 2 minus v, plus your constant, and then why do they give us this? Because it's some initial values, right? So equals 0 again, does it?
Anyone else?
Yeah, well you just get, when v is equal to 0, v equals 0, ln of 2 minus ln of 2. So c is going to equal to 0.
Done.
Just made my table.
Oh, I bet it was all the fault. You got the English. You gave me the kick I needed to get done.
Good man. Just G'd up.
English. Yeah, because it's 0, 0, ln.
Yeah.
Yep, 0,
Yep.
9.
Cool. And so our final answer.
T equals to 1 for ln of 2 plus v minus ln of 2 minus v.
So T is going to equal to 1 over 4 ln of 2 plus v minus ln of 2 minus v.
With no absolute values, you would.
Yeah, I'm a bit lazy, aren't I? Get back to it there. But then one final thing, you could probably put them under one log, hey, with your log laws. That's one last thing that they did. Right, so that's T in terms of V. So you can see like, these ones are quite abstract kind of questions.
So I didn't see.
The last one, sorry?
I didn't see still.
Classic for the definite integral.